Welcome to Study Loop.
Okay, so in this circuit diagram, we need to find out the current that's passing through the 16-volt battery, which is I1 for our case. And to do so, we have to follow Kirchhoff's law because we have a complicated loop with 4 resistors and 3 batteries. And we can see clearly that there are 3 small loops that's formed here. So if we have 5 unknown currents from I1 till I5. And since we have 5 unknown currents, that means we need 5 equations to solve for each of the currents. And since we see that we have 3 small loops, so we can have those 3 loops, and then to make 5 equations we can use 2 junction rule as well. Now the junction rule that we're applying is on the lower left. That means this point, and the lower right, which is this point. Right. So as we see here is I3 and I1 is going out and I4 is going in. So that's why I4 equal coming in. So I4 is equal to I3 plus I1. And for the lower right, I5 is coming in, but I2 and I3, uh, I5 and I3 are coming in, but I2 is going out. So that's why I2 is equal to I3 plus I5. Now, if we use the loop rule. So for left loop, we are using clockwise direction. So since I1 is with the direction, that's why we have, first of all, if we start from the lower left corner, we see that the battery is having a potential gain. That's why there's a positive 16 volts here. Then for I1, which is passing through 10 kilo ohm resistor, the direction and the direction of I1 are same, so that's why there's a potential drop, so we put a negative sign. And for I4, again, the direction of loop and the direction of current are in the same direction, so that's why there's a potential drop. So before we progress any further, we are assuming something here. So the assumption that we are making here is we are using kilo ohms instead of ohms in our calculation. So if we are using kilo ohms, so well, it's not like an assumption, but it's like a given fact. So yeah, let's call it fact. So the given fact is if we're using kilo ohms in our calculation, then for current we'll have our current in milliamps. So please take a note on that. So since we're using kilo ohms, so whatever current we get, we use milliamps as our unit. Okay, so moving on. So okay, our left junction is fine, our right junction is done. Then so yeah, left one is done, right one is done, then left loop is done. Now so let's talk about the right loop. So this one is the right loop, and for right loop we're using counterclockwise direction. And so if we start with the lower right corner, we see there's a potential gain because the battery is going from negative to positive, so that's why we have a positive 21 volts. Then our direction of current and the direction of loop is same, so that's why we have a potential drop, so we put negative 13 I2. And similarly we'll have negative 18 I5 because again the direction is the same. Then for bottom loop, we are again using counterclockwise direction, and if we start from the lower left, we see potential gain, so positive 12 volt. But now we have the direction of loop is against the direction of current, so that's why there's a potential gain here instead of drop, so that's why we put a positive sign here, so it's 18 times I5. Then I4 is in the direction of the loop, so that's why there's a negative sign, so it's 12 times I4. Great. So we have 5 equations now. So we'll be able to solve for any current. So let's proceed. So what we did here is we wrote the equations first. So that's the first equation. Just give me one moment, please. Okay, yeah. So that's the first equation, 16 minus 10i1 minus 12i4. So this is our first equation. This one is from our second equation, and this is from our third equation. And remember, these are all from loop rule. So what we did here is we substituted I4 from our junction rule. So if we put I4, the expression of I4 here, we'll have I3 plus I1, and that's what we did here. And then if we do a little manipulation and write the expression in terms of I1, we get something like this. And similarly, let me circle it properly. There we go. And similarly, what we did here is, for the second equation, we plugged in the expression for I2 here, which is I3 plus I5, and did a little algebraic uh, solving, and we got I5 in terms of I3. Right. So now we have an expression for I5 in terms of I3, and we have an expression of I1 in terms of I3. So if we look at the last equation, we have I5 and I4 in them. So let's see. Yeah, so what we did here is, again, we switched our I4 to I3 plus I1 right here, and then again wrote that in terms of I1 and I3 and I5 only. And since these two expression gives us the value of I1 and I5, or expression for I1 and I5, so we can easily plug these values over here, and that's what we did. So we plugged I1 from here, and we plugged I5 in here, and then we have only one parameter left, which is I3. So if we solve for it, we get our I3 as 1.189 milliamps. So here we're consistent with our fact that since we used kilo ohm, so we got our I3 milliamps. Now, once we know our I3, we can check what I1 is. So that's what we wanted to know. So I1 should be this expression, right? So it's going to be 16 minus 12 I3. So 16 minus 12. And for I3, we have 1.189. And then there's in denominator, we have 22. There we go. And then using this, I1 becomes 0.0787 milliamps. And if we write it a little neatly, it will be 7.9 times 10 to the power minus 5 amps, and the direction will be up because it's going up. Right. And for B, we need to find out VA and VB to get our VA minus VB. So we need VA minus VB. To do so, first we need to find VA, and then we need to find VB. So if we start from this bottom left corner and go till VA, we see the voltage is 16 volts. So our VA is 16 volts. And again for VB, we start from here, then we see there's a voltage gain of 12 volts. Then here there's a voltage gain of 21 volts up till point B. So our VB becomes 12 volts plus 21 volts, and that's equal to 33 volts. So that means VA minus VB will be 16 volts minus 33 volts, and that gives us our voltage as negative 17 volts. So yeah, that's the potential difference between VA and VB. Thank you.